Alright, hello everyone. Today we will be going through the EscapeRoom challenge on CyberDefenders.org. Let's just jump right into it. So the challenge details, the scenario is you belong to a company specializing in hosting web applications through KVM-based virtual machines. Over the weekend, one VM went down, and the site administrators feel this might be a result of malicious activity. They extracted a few logs from the environment in hopes that you might be able to determine what happened. This challenge is a combination of several entry to intermediate level tasks of increasing difficulty, focusing on authentication, information hiding, and cryptography. Participants will benefit from entry-level knowledge in these fields, as well as knowledge in general Linux operations, kernel modules, a scripting language, and reverse engineering. Not everything will be as it seems. Iniquitous files may turn out to be malicious, so take precaution when dealing with any files from this challenge. You have a few tools down here: Wireshark, Network Miner, Brim Security, UPX, and IDA. I will be using a few of these, although I will be using some other ones as well, other than these recommended. So let's get started. We have a whole bunch of tabs at the top here as well. We will be going through these as we're going through the lesson, or as we're going through this room. And let's have fun with this. All right, so what service did the attacker use to gain access to the system? If we open up the pcat file in Wireshark, we will immediately see all of this SSH. Now, to confirm that it is SSH, we can do a few things here. We can go to Statistics, we can go to Endpoints, and then looking under the TCP tab, we can filter by ports, and we see port 22 is SSH, 80 is HTTP, and all of these are called ephemeral ports, where they're temporary ports used by someone. You can see that they're all being used by 23.20. We will get to that, and we will get to this later. But you'll see how they're actually useful. Another way we can check is if we go to Statistics and then we go to the Conversations. And if we go to the TCP tab, we can check on port B here as well, and we can see a whole bunch of commands from port 22, and then some commands from port 80 here. So if we know the different ports, what we can do is we can go back to here, and we're going to go to our tabs, and we can see ephemeral port, and these ports are between 1024 to 65K. These are often temporary ports. The next one is HTTP. So this is on port 80. This is for your internet ports. For internet or HTTPS is 443, but that's obviously not here. And then our last one is secure shell, which is on port 22. And is used for remote login and command line execution. So if somebody got in, they got in through SSH. Okay, next one. What type of attack was used to gain access to the system? One word. So if we go back to the Wireshark packet, let's close this. We can actually see a bunch of SSH commands being used over and over and over again. This often means it's something called a brute force attack. Now, if we also look at the times, we can see a lot of these logins are happening in rapid session over and over and over and over again. So it looks like they're trying to crack the password. And there is a tool you can use for this. And it's actually right here. So this is called a brute force attack. I don't need that. And in this brute force attack, it's going to be submitting many passwords and passphrase over and over and over again, hoping to crack the password as quickly as possible. So that is the type of attack that was used. What tool was used by the attacker or possibly used to perform this attack? So, again, we go to another tab and say, we can use Hydra to brute force an SSH connection. So this, we can just Google this. We don't actually have to go through the Wireshark packet. We can just take a look and say, how do we do a password cracking over a network? And we use the tool Hydra. And that is the correct answer. How many failed attempts were there? So we know the answer. I know the answer is 52. I'm going to show you how to get it. So what we're going to do is we're going to open up the pcat file in Brim Security itself, and you're going to see this is another software we can use to do network analysis. And what we're going to do is we're going to type in this command here. I'm going to copy and paste it. And what this does is that it filters out a whole bunch of information. You'll see what I mean. So it filters out a whole bunch of SSH. Now what we're looking for is how many attempts were there. So this just filters out the SSH. Now we want to filter out and we want to count how many attempts there were. And we see that on this one we have 52 and 2. Now where they're coming from, the answer is 52. But where they're coming from is the amount of authentication success or failure. So because there's only true authentication, meaning it tried once, it succeeded, and then the person actually used that one to log in. So one was a scan, the other one was a login. So these two here, one of these had to be a scan, one of these had to be a login. Everything else failed. So if we go back to our previous search, we can see that how many failed, let's put that in correctly, is 52. If we go back to CyberDefender, we can see 52. So what credentials, user password, could have been used to gain access also have pseudo privileges, referred to the shadow log and sudoers log. So what we can do is we can open this up and we can take a look at the shadow log. So we're going to go cat shadow.log and we're going to see a whole bunch of users with their passwords hashed. Now we can take a look and see what kind of hash this is in just a second. So what we can do is we can also cat the sudoers log, which is this, and then we can see members of the admin group may gain root privileges. And here's a whole bunch of accounts. We can see guest, manager, Sean, Roger, Pierce. You get the point. What we're going to do is we're going to create a small text file containing these files, containing these different users, and we're going to crack the passwords, and we're going to have some fun with this. What we need to do before we crack these passwords is figure out the hash of these passwords itself. So what we can do, we're going to go back to here. Now I have this tab open, and we saw, let me go back real quick. It was $6. So if we go to our password hash, we go control find $6, $6, and we hit enter. Immediately, SHA-512 crypt. This shows up for Linux. This is a pretty much standard hash format for Linux machines, and you can see it looks very similar to the ones on our machine. Very, very similar. So what it means is that these passwords are being hashed with the, oh, where did it just go? There you are. The SHA-512 crypt. Now, it's also going to be named the 1800. So if we go hash mode 1800, that's the one we're going to use for our hashcat command. I'll show you how. Okay, so what I've done is I've taken the passwords. Oh, let's go back. Okay, so what I've done is I've taken some of the users from the shadow file and the shadow file and the sudoers file, and I figured out which ones are admins and which ones aren't. And we can see I'm using gedit, which is just a text editor. You can use any one of them. And once I do this, I'm going to save this as a file called crackme, and then I'm going to put this into a hashcat command. You're going to see. And the hashcat command looks something like this. We're going to use the rocku password list. So we go hashcat. We saw earlier that the mode we're going to use is 1800 because it is the SHA-512. So if we use it here, we're going to crackme, and then this is the password list we're going to use, and this is going to take a minute, so I'm going to hit enter, and then I will see you in a minute, or I'll see you in a second. Okay, so we can see here we have two cracked passwords, Forget and Spectra. We'll compare which ones, whose accounts these belong to, but you can see down here it started on August 3rd, and it took less than 5 minutes, almost 5 minutes. So if we take these hash passwords and if you want to take these hashes and these passwords and compare them, what you get is these two answers here. Manager is forgot and Sean is Spectra. Okay, so next one. What tool is used to download malicious files on the system? So this one we're going to use Brim Security. Open it up here. What we're going to look for is the path HTTP. I'll show you what I mean. By doing this, we're going to look at the HTTP commands, and we're going to see everything that happened over the web servers that we saw earlier on the Wireshark, over the wire. So we can see there's a get method here, but if we scroll to the right, we'll see user agent dubget. Now, if you don't know what dubget is, I have a little tab open here. Dubget is formerly get URL, is written as a package. It is used to retrieve contents from web servers. It is part of the GNU project. So dubget is a command on Linux that is used for pulling information from one web server to the system that it is on. And they must have ran this command in the SSH shell that they gained access to earlier, probably because they cracked the passwords through one of those two accounts. Now, on top of that, to double check what we saw, to double check our answer, we can type in dubget here as well, and we can also see it show up here. So we see user agent dubget right here. We can also see it here, dubget. We can check another one. That is looking funky. I don't know what that is. Here it is again, dubget, dubget, dubget. You get the point. So dubget was used to pull files from one web server to another. Now, before we continue, I do want to pull up one thing. I have a little piece here called Wondershare eDraw. What I'm going to do is I'm going to be drawing out this little network as we're going through this. So now that we've seen dubget, this is what our network actually looks like from the IPs. So 23.20.23 SSH'd into 10.252.174.188 and is doing dubgets to these different IPs. And I'll show you because we saw this earlier in our Wireshark PCAP. So if we go endpoints, we're going to see it here. So these are the 5 IPs that are being used. So 10, 23, 23, 174. So if we draw a map, if we go back to our map, this is what it looks like here. Okay, number 8. How many files did the attacker download to perform the malware installation? So what we can do is we can open this up in Brim. Let me clear this to show how I get here. So we're going to use our search from before, except instead of HTTP, we're going to put files instead. I want you to take a look at this. We see down here that there's 3 kind of unique ones. These are all images here. These don't seem to be important right at the moment. But we see 3 unique ones right here. And if we flip this and put the most recent, we can see 20, 20, 20, and then 23. So these 3 here were the ones that were downloaded by the malware. And I'll show you if we change the let me check. It's HTTP. We do the same thing with HTTP. We can see D1, D2, and D3. These are very suspicious. Now, these are also suspicious, but these are the 3 unique ones that are all linked together because these are all at the same time period. So, how many files did the attacker download to perform the malware? 3. So, what is the malware? What is the main malware? MD5 hash, and I'll show you how to find this. So what we're going to do is we're going to open up Brim again. Now instead of, we're going to check the HTTP, I have files here, we're going to put HTTP first because I want to show you, and flip this time, that if we check this D1 here, it showed up on my other monitor, and we scroll to the bottom, we'll see response MIME types application executable. So this means this is the actual malware here. And if we switch this to files, we swap this, we can also see application executable. And we can see the hash here is 772B . So there's the hash of the executable file. That is the main malware. We're going to be taking a look at that malware later, but that is the answer right there. Next one. Number 10. What file has the script modified so the malware will start upon reboot? Now this is a bit of an interesting one because I couldn't actually find this in the Wireshark, so I had to do a lot of Googling. And the Google search I used was Linux Startup Commands Superuser. Now, the 2 websites that worked were superuser.com here and superuser.com here. And the 2 ones that are run commands as startup as root. And we can see right here, original obsolete. You can try putting the commands in etc rc local. Commands in this file should be run at the end of the boot sequence, which is when you start up. The other one that also confirms this is where and how are custom startups commands configured in Linux. After Googling, we find that there's another confirming this, saying one simple place to put your script, although not distributions use it, maybe run at system boot time is etc local. So, if we type in etc local, it's actually correct, and I can confirm it's correct by going into the Wireshark PCAP here. I'll show you how this works. Let's clear that. We go rc.local, and we get 1 hit. Not only that, we get 1 hit, and we can follow the TCP stream, and sure enough, this is the malware execution. This is very suspicious. We can see what's going on here. var mail mail, var mail mail, var mail. There's a whole bunch of nonsense going on here. This should not be happening, so I can confirm that it has modified a script inside the etc local, and actually let's go back one more time. The etc local is right here. So it's clearly doing something, putting a whole bunch of files in the RC local, which is initiated on startup. So we can go even further. Where did the malware keep its local files? Well, we can check again. Not Brim, Wireshark. It kept it in its local varmail, but I could show you in another way. And what we're going to do instead is we're actually going to use virus total. And what we're going to do is we're going to punch in the hash file. Just give me 1 second to find it. Here it is. If we put in the hash file here, it will show up as malware. Now, one thing I found is that if you go to community, and then you go to the PDF report here, Joe Sandbox, and you go to here, this is the entire PDF. What you search for is startup, and if you scroll down to the page just below, you will see wget output file and varmail 282084. So it's clearly doing something with the varmail. Clearly. It's shown in the Wireshark. It's now showing in the malware report that it is doing something with the varmail directory. So if you go back to this, where the malware keeps its local files, somewhere in the varmail. Now, what is missing from ps.log? If we go back to Wireshark, I know we're jumping back and forth here, but we can see, let's read the question one more time. What is missing from the ps.log? We can see this command right here called nohup varmail mail dev null 2 greater than and 1 and. So nohup, and I have the command here, means no hangup. The purpose of this is to execute a command such that it ignores the hangup signal, therefore does not stop even when the user logs out. The second part of the command is dev null 2 greater than and 1. This is used to take all of the command line and discard it completely. So if you see here, it is immediately deleted, which is used to discard output from programs. So if you want to get rid of a certain information, it's going to take all the data from varmail and completely throw it in and just completely discard it. So that way, when we go back to our, and I'm jumping around here, when we go back to our ps.log, we can see varmail is not in here. Varmail is not in the logs because it is being discarded by the malware itself. So, we go back to this, we go back to our CyberDefenders. What is missing? Varmail mail. Because in our Wireshark capture here, we saw varmail is being discarded. So there are no logs for varmail mail. I know I'm saying it over and over. It is not in there. That is the answer. That is the reason that is the answer. What is the main file that is used to remove this information from ps.log? So we saw in our Brim security, let me go back to HTTP. We saw D1, D2, D3. So 1, 2, 3 is actually the name of the malware. And you heard me earlier talking about this. So what we see here is move 1, move 2, and then RM3. This is the malware right here. And I know this is the malware because move 1 is actually renaming the malware to what looks like a directory. And I'll show you what I mean. If we go to another one of my tabs, we can use the move command to rename files, and instead of while moving them to a path, or we can just rename the file itself. So what we see in the Wireshark capture is renaming the malware 1 and renaming it to varmail mail. I know I'm saying it over and over again, but this is what's happening. It's then making it executable, and then something is going on here where it's sleeping for 1 second. I actually don't understand this command completely. Hopefully someone can teach me about this. And then it's putting this command into the RC local where it will be used on startup. Now, the question was, let's go back. What is the main file that was used to remove this information from ps.log? It is sysmod.co, and the reason I know this is because if we go into this, we are renaming the number 2 file, so 2, we're putting it in the lib modules, and this is uname.r. This is just going to get the kernel version, and it's renaming it to sysmod.co. So this is actually being renamed from, it's taking the number 2 and then renaming it to sysmod.co. Cool. Now, here's where we get even crazier, because now we're going to be doing some reverse engineering. So inside the main function, what is the function that causes requests to these servers? Now, in here, we're going to be using a tool called Ghidra. Now, this is a bit of a new one. It can be a bit overwhelming, and we'll walk you through it. So I'm going to start here. We're going to open up. We don't have to type that in. We can type in here, Ghidra. Now, you might see a previous project I was working on here to test this to make sure I was getting it correctly. Oh, perfect, it's not here. So what I'm going to do is go out, File, New Project, Non-Share, that's fine. We can keep it in our walkthrough, that's fine. File name, that's fine. Project name, we're just going to call this malware. Oops, let's call this EscapeRoom malware. Let's also spell that correctly. We're going to finish, and it's going to open it up. So now we have this. Now, before we open up the malware, we have to download the malware from the Wireshark PCAP. So how we're going to do that is we don't need this. We can keep that open, actually. We're going to get rid of this. We don't need this. We're going to RC local. I'm going to go File, Export, and we knew it was over HTTP, and there's the file right here, 1, 2, 3. We can export all of them. You can export all of them. Take a look at yourself. These are just images. Some of them are actually kind of funny. I encourage you to take a look at them yourself. So what we're going to do is we're going to click number 1. We're going to save it. And I'm going to save it inside my escape room folder. So, not there. I know, I have it twice, I know. And what we're going to do is we're just going to call this malware. We're just going to call it malware. So we're going to save. Fantastic. Go back here. ls. I know there's a whole bunch of files now because we've now opened a big Ghidra project inside this directory. So there's malware here, but right now it is compressed. So what we're going to do is we're going to uncompress it first. And we saw during the initial setup, let me scroll up real quick, we're going to use something called UPX. And what UPX comes with Kali Linux, and UPX is going to decompress the file itself. So let me do a quick check. Let me check my notes. So the command we're going to run is called UPX, and we can see it here actually. I've already typed it out before. This is just me demonstrating it again. So we're going to decompress the malware, and this -o is the output file, and we're going to spell this correctly. I can't have misspellings. We're going to call it malware decompressed. Perfect, it is now done. We're now going to take the decompressed malware and take it into Ghidra. So check this out. So if we open up the file here, we're going to see it is malware decompressed. If you can bring the malware into this, you'll see it's not going to work. So I'm going to go to OK. It's going to do its thing. Click OK, that's fine. Double click malware, and little dragon is going to open, and we are now going to start reverse engineering this malware. This is super exciting. Now, we're going to analyze it. That's fine. Analyze it, let it do its thing. It's just going to do it for a couple seconds. Unless you have a potato, then it's going to take forever. And it's done. So, the question was, in the main function, what is the function that causes requests to these servers? Well, we can just search that up. We can just type in here and type in request. And there's our answer. Request file. This is the function inside main, which gets files from the server. It's pretty straightforward, isn't it? I know. When I first started learning this, it was really overwhelming, but I managed to get it. If I can get it, you can get it. So, one of the IPs of the malware connected starts with 17. Provide the full IP. Now, there's two ways we can do this. Well, it's actually one main way we do this. We go through Wireshark, and we can take a look at here, and then here's the answer right here. What I happen to do, which I thought was pretty nifty, is I actually made a little map for myself. Is the initial attack started from 23.20 SSH, and then over time it made different HTTP get requests. So the IP we're looking for is 174.129.57.253. How many files did the malware request from the external servers? So from this one, we can actually go back into Brim, and we can see this is the malware here. We can just count these 1, 2, 3, 4, 5, 6, 7, 8, 9, because these three here you can see 20, 20, 20, or 2029, 2029, 2029, and then here's where all the other files are being downloaded. So our answer is 9. Now, the final question, number 17. What is what are the commands that the malware was receiving from attacking servers? Now, this one is annoying, but I managed to figure out, and it is really cool how I managed to figure this out. And you're going to like this too. So I'm going to go back to Ghidra. Let's open it up. And what we want to do is we want to type in main. So main is going to show up, and software engineers are not very creative. All of them use the same variables over and over and over again. So if we go to this and we double click main and we take a look at this, we can see that this is the main process. So instead, it's actually not going to be in main, but it's part of main. We can look through all of these, and we can see different functions like copy message, decrypt message, encrypt message, extract message. I spent hours going through all of this trying to find the answer. The one we're looking for is under process message, and it makes sense that it's under process message because it says, hey, now that I got the message, what do you want me to do? So we have two things here. If parameter 1, we have what's called this is a hex code, and then if else parameter 1, this is a different hex code. So these are clearly different scenarios and different inputs. Now I'm going to put these two hex codes on screen so you can see, because I'm going to take them off the screen just real quick. If you take these and put them into a hex code to ASCII, it'll look like this. So if we convert the first one here, let's kill this so I can show you what it means. So the first one is 0x4e, and it ends in 5000. So there's NOP. And the next command we have is 52. There it is, run. Now, what are these commands? NOP means no operation, meaning don't do anything. Do nothing, literally nothing, null. Not zero, not nothing, don't do anything. Run is just execution. The term run is almost synonymously to run and to execute. So it's either A, don't do anything, or B, run the execution. And those are the last two answers here. I am so happy I completed this room. This is a very challenging room. This goes into the more intermediate levels. I hope you guys learned something. I learned so much from this room. I hope you guys had a great time too. Yeah, have a great day. Bye.